Explore API token security in Flask, focusing on authentication and authorization patterns. We'll delve into token fundamentals, implementation strategies, security best practices, and production deployment considerations. Token-based authentication is crucial for modern Flask APIs. Tokens, particularly JSON Web Tokens, offer a stateless, scalable solution for API security. They encapsulate user identity and permissions, enabling seamless integration across microservices. Understanding token structure and implementing secure generation, validation, and refresh mechanisms are essential for robust API security. This approach supports horizontal scaling and enhances mobile and single-page application compatibility. Traditional session-based authentication requires servers to store session states, leading to challenges in scaling and service coupling. In contrast, modern token-based authentication is stateless, facilitating easy horizontal scaling and seamless integration across microservices. This approach is particularly beneficial for mobile and single-page applications, ensuring robust security without session affinity concerns. A JSON Web Token, JWT, is composed of three parts: the header, payload, and signature. The header includes metadata like the signing algorithm. The payload contains user claims and data. The signature, created using HMACSHE 256, ensures data integrity. Each component is vital for maintaining security in token-based authentication systems. Setting up Flask JWT Extended involves configuring critical security settings. Use environment variables for JWT, secret key, set token expiration with time delta, and choose a secure algorithm like HS256. Regularly rotate your secret key to maintain security. Short-lived access tokens reduce risk, while refresh tokens allow re-authentication without storing credentials. Token generation follows credential verification. We use Werkzeug to securely hash passwords, ensuring user data protection. Upon successful login, access and refresh tokens are created. These tokens include additional claims, such as user roles, embedded in the payload, reducing database queries for each request and enhancing efficiency. Using RAWT required ensures only requests with valid tokens access protected routes. Get JWT identity retrieves the user ID, while Get JWT checks claims like roles. If a token is missing or invalid, a 401 error is returned. This decorator pattern simplifies root protection, allowing focus on business logic while maintaining security. Refresh tokens enhance user experience by allowing new access tokens without re-entering credentials. The refresh endpoint, secured with AGIWT TRA required, refresh true, issues a new access token using a valid refresh token. This balances security with usability, as access tokens are short-lived, while refresh tokens are long-lived and stored securely. Token storage on the client side requires careful consideration. Local storage is vulnerable to cross-site scripting attacks, exposing data to malicious scripts. HTTP-only cookies are recommended, as they are immune to cross-site scripting and automatically sent with requests. Memory storage offers the highest security, but loses data on refresh, suitable for sensitive applications. Use HTTP-only cookies with secure and same-site, strict flags for optimal protection. Implementing cookie-based tokens enhances security by using HTTP-only cookies, which prevent JavaScript access, and the secure flag, ensuring HTTPS transmission. Cross-site request forgery protection is built in, adding an extra defense layer. During login, access tokens are set in cookies, and during logout, they are removed, maintaining a secure session management process. Token blacklisting is crucial for security, especially during user logout from all devices, suspected token compromise, or permission changes. Implement a block list to revoke tokens using Flask JWT Extended. Use Redis for production to manage token expiration efficiently, ensuring tokens are invalidated promptly during critical security events. Rate limiting is crucial for defending against brute force attacks. Using Flask Limiter, you can restrict login attempts to 5 per minute per Internet Protocol and application programming interface requests to 100 per hour per token. After 10 failed attempts, a 15-minute lockout is enforced. Redis backend ensures scalability in distributed systems. HS256 uses a shared secret for signing and verification, making it ideal for monolithic applications due to its simplicity and speed. RS256, with its asymmetric key pair, is better suited for microservices, allowing public key distribution without sharing secrets. Always avoid the none algorithm in production for security reasons. Implement RS256 in Flask by loading your private and public keys using the cryptography library. Configure your app with RS256 as the JSON Web Token algorithm, setting the private and public keys accordingly. Generate RSA key pairs with OpenSSL, ensuring private keys are stored securely and never committed to version control. Custom claims enhance authorization by embedding user roles, permissions, and subscription tiers in tokens. This reduces database lookups, improving efficiency. Use decorators to enforce permissions, ensuring only authorized users access specific routes. Keep claims minimal to optimize performance and avoid sensitive data in tokens, as they are base 64 encoded, not encrypted. Token expiration is crucial for balancing security and user experience. High-security apps use 15-minute access tokens, while most web apps opt for 1-hour tokens. Refresh tokens, lasting 7 to 30 days, allow seamless re-authentication. Remember Me extends sessions to 90 days for trusted devices. Tailor expiration times to your app's risk profile, using sliding windows when needed. Handling token errors is crucial for security and user experience. Use specific error callbacks for expired, invalid, missing, or revoked tokens, returning clear messages and 401 status codes. This allows clients to handle errors programmatically while maintaining security. Log invalid token attempts to monitor potential attacks without exposing sensitive details. Testing token authentication is crucial for security. Use PyTest to verify access control. Test routes without tokens should return 401. Valid tokens should allow access. Check token expiration by using expired tokens, expecting a 401 response. Test invalid token signatures to ensure they are rejected, maintaining robust security protocols. Avoid the none algorithm attack by specifying allowed algorithms and rejecting none. Use cryptographically random secrets of at least 256 bits to prevent brute force attacks. Sanitize logs to prevent token leakage. Enforce HTTPS with HSTS headers to secure token transmission. Validate all claims, including expiration, to prevent replay attacks. Store JWT secrets securely in environment variables or secrets managers, not in code. Rotate secrets regularly. Enforce HTTPS with SSL TLS certificates and HSTS, redirecting HTTP traffic at the load balancer. Use Redis for token blacklists with TTL, ensuring persistence and replication. Monitor authentication attempts, token errors, and rate limits, setting alerts for anomalies. Implement logging for authentication attempts using decorators to capture success and failure events. Monitor a 95% authentication success rate and average 2.3 failed attempts per user. Track token revocation rates under 1% to identify anomalies. Use these metrics to detect potential security threats and ensure robust monitoring. Stateless tokens facilitate horizontal scaling by allowing each application instance to validate tokens independently, eliminating the need for session storage. Load balancers can distribute traffic without session affinity, enabling dynamic scaling. For distributed token revocation, Redis Cluster offers high throughput with sub-millisecond lookup times, automatic sharding, and built-in replication, ensuring resilience and efficiency at scale. OAuth 2.0 integration with Flask involves using Authlib to register third-party providers like Google. After user authentication, a JSON Web Token is created for consistent application programming interface access. This process includes setting up client credentials, redirecting for authorization, and parsing identification tokens to generate access tokens, ensuring secure and seamless user authentication. Token caching is crucial for performance, reducing central processing unit usage by 40–60% by storing decoded payloads in memory. Minimize payload size by removing unnecessary data, saving bandwidth. Optimize blacklist lookups with Redis pipelining and Bloom filters, cutting latency by 30–50%. These strategies enhance efficiency and scalability in authentication systems. Prioritize security by using strong secrets, HTTPS, and HTTP-only cookies. Implement token refresh, revocation, and rate limiting. Constantly monitor authentication metrics and set alerts for anomalies. Stay informed on JSON Web Token vulnerabilities and review Open Web Application Security Project guidelines. Utilize resources like JSONWebToken.io, Open Web Application Security Project API Security Top 10, and Flask JSON Web Token Extended Documentation for best practices.